Welcome back to the CAN bus introduction series. In our last video, we explored the CAN_send sketch. Today, we'll delve into a new sketch, CAN_led, focused on receiving messages from the bus and applying practical functionalities. Building upon elements from our previous sketch, this episode will demonstrate how to make the most of the data received on the CAN bus. To access the CAN_led sketch and related resources, you can find the GitHub repository linked in the video description. The first 20 lines are not changed from the previous sketch, however you will notice we have declared a global variable for the LED to be attached to pin 7. This allows us to use the variable name LED_pin anywhere within the sketch. It is good practice to use variable names rather than using numbers to describe the pin you want to toggle. In the void setup function I have added the line pin mode, LED_pin, output. You can see I have declared two parameters for this. The first is telling the IDE to use the global variable LED pin, and the second one configures the specified pin to behave either as an input or an output. Next we will take a look at the void loop function. In the previous sketch we used the void loop to send the messages out onto the bus. However, in this sketch we are not going to use the void loop to do anything. This is because this sketch is only going to be a consumer on the bus. It is going to use an interrupt ISR function. Void receive ISR, this line declares a function named receive ISR with a return type of void. The void return type means that the function does not return any value. The line unsigned long RxID, this variable is of the type unsigned long and is intended to store an identifier or ID for a received message. The use of unsigned long means it can hold a large positive integer. uint8_t len, this variable is of type uint8_t, an 8-bit unsigned integer. It will store the length of the received message. uint8_t can represent values from 0 to 255. uint8_t rxbuff, 16, this declares an array named rxbuff of type uint8_t with a size of 16 elements. This array stores the actual data of the received message. The use of uint8_t means that each element in the array can hold an 8-bit unsigned integer. Next we have an if statement, if, can.checkReceive, this line checks if there is a message has been received on the bus. If a message is available it moves to the next line, can.readMessageBuff, RxID, len, RxBuff, the code proceeds to read the message using the readMessageBuff function. This function is part of a CAN library and is used to retrieve the details of the received message. We have specified three parameters. An RxID, this is the address of the RxID variable declared earlier. The function will populate this variable with the identifier of the received message, and len, this is the address of the len variable declared earlier. The function will populate this variable with the length of the received message, RxBuff, this is the address of the RxBuff array declared earlier. The function will populate this array with the actual data of the received message. The next line of code, unsigned, int standard ID equals RxID in 0x7ff, this is used to mask out extended bits to get the standard 11-bit identifier and not use the 29-bit identifier. These lines use the serial object to print a message to the serial monitor. It prints the message ID in hexadecimal format by using serial.print, standard ID, GX. The message is formatted as received message ID, 0x, followed by the hexadecimal representation of the standard ID. We then have a for loop which iterates over the elements of the RxBuff array, printing each element as a character to the serial monitor. It assumes that the data in RxBuff represents ASCII characters. The final serial print moves the cursor to the next line after printing the received message details. We next come to the first if statement which check if the received message is on. This line is an if statement that checks three conditions. Len equals 3, checks if the length of the received message is exactly 3. RxBuff 0 equals O, checks if the first character of the received message is the letter O. RxBuff 1 equals N, checks if the second character of the received message is the letter N. If all three conditions are true, the code inside the if block will be executed. When true, the digital write function will use the two parameters specified to set the LED_pin to the high state turning on pin 7 LED. The second if statement is checking to see if the message received corresponds to off, in which case it will turn off pin 7 LED. If you find these videos useful, please help to promote them. This is easy, it just requires you to either like or dislike them. This helps with the YouTube algorithm, as it sees people are interacting with the videos. Also, comments help me to make the content better.